Alrighty, today we're taking a look at question number 3 for the 2-week homework, and I think this is homework number 3. So this one we're trying to find the voltage across each capacitor in this series that they're connected in series. So we have one here, here's our 2 microfarad, and then that's connected to our 4 microfarad one. Okay. And then once they're charged, so we're given that they have a 3 kilovolt potential, which is our 3,000 volts. So once it's charged, then we disconnect them, right? So first let's start by finding the charge that they're charged to. So our net, since they're connected in series, our equivalent capacitance is going to be, our 1 over that is going to be 1 over, and I'm just going to keep everything in terms of these microfarads right now. We'll look at it again in a second, but it's going to be 2 plus 1 over 4, right? And that's going to work out to be 3 over 4, which when we flip, we get that our CEQ is 4 over 3. Sorry, trying to remember how to do math for a second. So now we have the charge of we have our equivalent capacitance, and now we can use that to get our 4 over 3, right? When we have our equation that's C equals Q over V, we can have our 4 over 3 there equals our charge over our voltage. We have our voltage, we're solving for the charge, so that's going to be Q equals 4 over 3 times, again, when I said our 3,000 volts that were up there. And that's going to give us 4,000 coulombs. Or not coulombs, some other type of something, because we're in microfarads right now. Either way, 4,000 charge for right now, right? So then once we disconnect them, they're disconnected from the source, but then they're connected to each other with the terminals of like sign together. So before we had our plus minus, right, for each of our, that would be a plus Q, minus Q, plus Q, minus Q. So now when we connect them with like charge, we had what was our, I'm just going to take this drawing and move it down out of the way for a second. So we have our 2 microfarad right here. This had our 2 here. We have our plus here. We have our minus. And again, all of these we're going to have the same 4,000 charge. So we connect that to our plus and minus here. All right, we're connecting like this. Suddenly, we can almost envision them like they're one big capacitor, like we would if they were in like series or parallel, right? So the charge on this side now is going to be our 1 Q from up here plus our other Q from down here. So now we can say that our capacitance of this system, right, is going to equal 2Q, because it's going to be 2 times that charge over V, because the charge is just going to be twice as greater as it was before, right? And this capacitance, since these 2 capacitors are now connected in parallel, right? If we had like 2 more wires going off this way, these would just be in parallel. So now our capacitance is going to be, and this one was our 4 microfarads down here, right? Our total capacitance is going to be 2, again, plus 4. So now we have our charge, because again, this Q is the same as this Q. We're just multiplying it by 2 to get the new total Q, right? We have the charge, we have the capacitance, and we're solving for this voltage. So what we're going to do is we're going to say that the voltage equals 2Q over 6. Because remember this, whatever this unit was, this one was based in terms of our capacitance calculated from the microfarads up here. So if we use microfarads again, then it's going to kind of like cancel out and we're going to still be in the volts that we want to be in. So if we have our 2Q, that's going to be about 8,000 over 6. And like evaluating that out is going to get you whatever decimal is your answer for the total voltage across the capacitors. All right, so I hope you found this at least a little bit helpful. Let me know if you have any more questions about this problem or any other problem that you want me to try to explain, and I will do my best to explain it because I guess Sydney explains stuff.